Hi guys, I will be starting with C++11 New Features Part 3. So this will be covering features that are overlapping and delegating constructors, and the other feature that is converting constructors and explicit. So guys, in the introduction part for this C++11 new features which I have covered earlier, I have already described. I have divided this C++11 new features into different parts from part 1 to part 8 so that it will be convenient for your purpose. So I have divided it into small features actually, so you can refer it in one go itself depending on what features you want to revise, guys. So guys, this is a summary of the features which I have covered in the previous parts, that is part 1 and part 2. So I have covered auto initializer list in the part uniform initialization in the part 1, and in part 2 I have covered null pointers and static assert. So guys, in this part 3, as I told you, I will be covering these two features that are the overlapping and delegating constructors, and then I'll be covering converting constructors and explicit. In this manner guys, we will be covering all these features, different features till part 8, and this is how we'll be completing all the C++11 new features. So guys, let's start with overlapping and delegate constructor features which C++11 provides you. So guys, this is a snippet of code for your reference. This will clear what this feature is all about. So guys, you are having a class sample in this manner, wherein the constructors are public. There are two constructors. One is having no argument and one is having one argument, guys, the constructor. And guys, these two constructors actually, so in this first constructor which is not having any arguments, you are having some portion of the code actually. So this same portion of the code, guys, in this constructor which is having one argument is repeated here. So I've just written same instruction for code 1 here in this constructor and same instruction for code 1 in this constructor. So these two constructors are there, wherein this line of code, whatever instructions are there here will be also repeated here itself. And then code 2, that means different instructions are there. So set of instructions are common in these two constructors, and then this is having a unique instruction, different instruction, guys, for this. So this first set of code is the same for this two of the constructors, and then the next instruction is different for this particular constructor. So let's see actually what does it mean, what will happen. So guys, here you can it leads duplicating code in both constructors, which we should avoid. So you see here, as I told you, this two constructor, which is one constructor with no argument with constructor with one argument, they're having duplication of the code because the set of instructions which is there here is also present here itself. Beside, this is another code too. So you should not. So this is, it says actually that duplication of the code in both constructor you should avoid, guys, because you can understand it leads to deficiency and efficiency because repeated code is present. So you should avoid repetition of the code. So let's see how C++11 provides this, how it gets rid of this issue actually. So since you should avoid repetition of the code, always it is preferred to write a short efficient code without repeating the code, guys. So let's see how C++11 will get rid of it. So there are two ways which C++11 provides you. You can avoid repetition of code. One way is in this manner, guys. You are having the same class actually. You are having one constructor with no argument, one constructor with argument. So you can see here, guys, in this constructor you are simply calling this constructor itself. That is the constructor which is having no argument. So since in the previous case we have seen that this constructor which is having no argument is having instructions which is common, same instructions which is common to this instructions which is present in the constructor which is having argument. So instead of writing repeating code, you are simply calling the constructor itself with no argument, because when it calls this constructor with no argument, so you will get all the instructions which is present in this constructor. You don't need to repeat the code again. So guys, this avoids the issue which was there earlier. This will avoid you repeating the code. So this will increase the efficiency. Second way actually which you can achieve is in C++11. You can also write this constructor in this way, and the constructor. So instead of calling the constructor with no argument here, you can directly write colon and then in this manner. So since you will write in this manner, it will call this constructor, guys, and then you will get this instruction. So you don't need to repeat the code. So this is how, guys, this chaining is provided by the C++11 provide you this feature actually. Also through function you can achieve this. How? You're having this class sample, you are making your function as private, you're having this code which you want to be called through another constructor. So you're writing some function actually, and whatever code you want to execute in both constructors, you will be writing in this particular function which you will make private, so that the member functions can only call this particular function and not the class outside a class. So guys, you are making the constructor public and you are calling this particular code, this function actually. So this function will be called, and also this constructor which is having with one argument, you are calling this function here. You are also calling the same function from this constructor itself. So this is different way in which you just write a common piece of code in one function, and you from both of the constructor which is having no argument, constructor which is having argument, you call these functions. This is how you avoid repetition of code. So what is the conclusion, guys, from this? Starting with C++11, constructors are allowed to call other constructors. So you can see in C++11 it allows you call one constructor from one constructor from the other constructor. So this is allowed in C++11, and this process is called as delegating constructor or constructor chaining. So since you know the name of the feature is delegating constructor, delegating because one constructor is delegating to another. So that means there is a constructor chaining, guys. So this is possible only with C++11. It is not possible with C++. So this is a new feature which C++11 has provided in order to avoid repetition of code, in order to achieve efficiency. So guys, so this is so guys, here you can see the additional note, about delegating constructor. So guys, first a constructor, this you should make a note, guys. This is very important. It's a note point. So let me write here because it's important actually for this feature. So guys, the additional note about this delegating constructor is, first, the constructor that delegates to another constructor is not allowed to do any member initialization itself. So guys, whatever the constructor, whosoever the constructor, suppose the constructor 2 is delegating to another constructor, say this constructor is there, so it is delegating this constructor. That means it is calling this constructor actually. So this constructor which is delegating this constructor. So this constructor who will be delegating is not allowed to do member initialization. You know what means member initialization in the cell. The data member which is there in this class, this constructor is not allowed to initialize that data member if it is delegating to another constructor. If it is not, if this code is not present, guys, then this can do the member initialization. But if this code is present, that means this constructor with one argument is delegating to the constructor with no argument. So in that case, it is not allowed to do any member initialization. It can either delegate or it can either do member initialization. It can do any one of them, but it cannot do both of them. So this is the note point actually. And the second thing is, it's possible for one constructor to delegate another constructor which delegates back to the first constructor. This forms an infinite loop and will cause your program to run out of the stack space and crash. So guys, you are saying, since you know that one constructor can delegate, this constructor is delegating to this constructor. If this constructor is delegating to previous constructor, suppose there is one more constructor and that is also delegating. So this is chaining. This will lead to infinite loop. So you should avoid all these case actually, because this will cause, there won't be a space, guys. So it's saying it can also lead to the crash. So please avoid all these things. Actually, these are the note points, guys, which you should remember. Actually, you can also refer it later for your reference. Actually, I made a note for it, guys. So this is all about delegating constructor, guys. So see another feature actually, that is converter constructor and then explicit. Let's see. So what is converter constructors? What is explicit? Let me explain you in detail, guys, here. So constructors eligible to be used for implicit conversions are called as converting constructors or conversion constructors. So this is the meaning of the converting constructors. Whenever your constructor is eligible to use for implicit conversions, that means some implicit conversions, if your constructor is eligible to do the implicit conversions, then it is called as converting constructors. So it will be more clear when I explain you through program, guys. So prior to C++11 only, the constructors can take one parameter could be converting constructor. However, with the new uniform initialization syntax in C++11, this restriction was lifted and construction taking multiple parameters are now allowed to be a converting constructor. Example as below. So guys, this example will explain you what does it mean. So what is converting constructor? So guys, in C++ you already know, whenever you are having constructor, whenever you are having one argument actually, so that can behave as an implicit conversion. You have seen implicit conversion in C++. That suppose you are creating an object of a class and you are passing some parameter to that particular object. So that is having different data type, and if you are having constructor, one argument constructor of different data type. So guys, in that case actually there will be implicit conversion taking place in case of C++. So that is called as implicit conversions because different data from one data type to another. So that is an implicit conversion. So guys, but in C++ we have seen this is possible with only one with the constructor having only one argument, not two arguments. So this is what this is saying about, that in C++ you have seen implicit conversion taking with the constructor which is having only one argument and not two argument. But in C++11 it will provide a constructor doing implicit conversions with two arguments. So this is what all about this description. So it will be more clear by the example how by two arguments it is possible. So guys, this is a class sample. You are having two data member which is private. You are having the constructor public. You are initializing this data member, whatever is passed through main function, creating an object and passing two arguments that will be filled actually and in case of this constructor. So guys, this is a function where you are having some piece of code. This is outside of the function, outside of the class sample, and then you are creating the object here. So you are having one class sample which is having its two data members as private, which is having one constructor and wherein initialization is taking place. Then you are having one function which is outside this class and you are creating an object in this taking as an parameter, and there is some piece of code in this function. Let's see what will happen in case of. So guys, here what happens, you are calling function 6. So you are calling the function, you are passing the argument 6. So you can note this 6 is an integer. So guys, what happened when this function is called, then it is 6 is passed as an argument to this. So therefore you will have sample s is equal to 6. This is simply you are creating an object of the sample and you are passing argument as 6. Therefore your constructor with one argument should be called. So guys, you are having a constructor with two arguments, so no issues. This will be this constructor itself will be used actually, and there is a default initialization. So since one argument is only passed one, so one variable will be set, another variable will be set as it is by the default one. So this is the scenario, guys. So while doing the implicit conversions makes sense in the fraction case, in other cases this may be undesirable or lead to unexpected behavior. So in this case, guys, it's not an issue actually. This is a simple case since you are having the constructor which is having two arguments. Both of the arguments actually is a integer. They are integers, so not a problem. You don't have. So even if this particular, so this is allowed in C++11. So guys, if this function is called, since you are passing as an integer, and this constructor will be called, one will be set actually with what you are passing actually from the main function, and another will be set to default one, that is 1. So this will be used for implicit conversion. This is okay till same data type is used, that is integer for implicit conversion, no issues. But what will be the scenario for another case? So guys, what will be the problem actually in another case? I mean to say, this will be working fine actually in this case, since it's a different, same data types are used. You are passing integer and the constructors is also having two arguments as an integer. But when if data types are different, what can be problem? Let's see. So guys, this is, you are having a code. You are having a class custom string. You are having the data member as a private. This is also a string. So you're having a class name custom string. You're having a private which is having data member as string. So you are having one argument constructor. So by this particular data member, this is, since it's a string, you are calling this function resize, and whatever argument is passed in this constructor, you are resizing that A. So guys, one more constructor you are having, which is having const char star. So this is a constructor which is having const char star as an argument. So two constructors are there. One is having integer A, one is having const char star. And this is what the data member is initialized to str. So let's see guys, in the main function. So you're having one friend actually, that this particular function is a friend actually of this class custom string. So this is this function, it is operator. This, you know guys, this operator is for printing on the console actually. This, you know, this operator is used in C++. So you are making this particular operator this as a friend of the class custom string guys, and you are defining it outside actually of this class. So this is what you are defining. You are simply using this object actually to print this particular string, that is the data member of the class. So let's see guys how it works in case. So guys, since you know your entry of your program starts, execution of a program always starts from the main function. So when you compile the program, the control comes into in this main function, and whatever line of instructions you will be giving, that will be executing line by line. So guys, therefore this particular instruction will be executed first. What does it mean? It is creating an object of this class, say custom string. So this class is here, as in I told you there are two constructors present in it, one data member which is private, one operator that is cout operator which is friend actually. So this object, you're creating an object in this main function, that is str, and you are passing this, you are initializing in this particular object with this character. So you are having an object, and that is having the argument actually as a character. So guys, therefore the constructor will be searched with one argument actually. So guys, since there are two type of constructors, one const char star str and one constructor with integer A. So this will be called actually, because you know character integer, they are implicit conversions can take place. So guys, what will happen, since you are passing here a character actually, and you're having a constructor with this integer. So guys, you can understand this particular character will be then typecasted to this integer actually. And guys, in this particular constructor, you are doing resize of A. So this will happen, this it will do the resize of this integer. So guys, you can understand actually you are passing a character from the main function, but since here this will be typecasted to integer, and therefore resize of integer will happen and not character. You can understand how this will differentiate the code. Since you are if it was displaying the message, then it was different, but this is directly resize actually. So resize deals with different data types. Is different for integer, different for character. So in this case guys, then you will be printing in this value actually. You are printing this str. So guys, this str, when you print it actually, then this will be printed. This data member will be printed actually. So this is resized, and you are printing actually this value. So guys, here you can see in this manner. So this is a note point for it, what problem can occur. Here above implicit conversions, when instruction this will be called, this is executed, then unexpected result occurs when str is printed on console by cout this, because this resize A behaves different for integer. As in I told you guys, you are calling directly the resize function. For integer, for character, it is different actually. Therefore your unexpected behavior will occur in this case actually. So guys, how you can address this issue, how you can fix this issue actually. So one way to address this issue is to make the constructors explicit through the explicit keyword. So this is how you can fix this issue since you don't want this implicit conversion. So guys, in this case actually you can understand that when this particular object is created and this character is passed, you don't want actually this constructor should be called actually, because it is not having a character as an argument, it is having an integer. So you should make this constructor as explicit. What will happen if you make a constructor explicit? So if you make a constructor explicit actually by writing explicit keyword in before this particular constructor name, then this particular constructor will not be called, because since implicit conversions are possible, if you don't want any this constructor to do the implicit conversion, you can simply write explicit keyword before this. So you can fix this issue actually, because as you know this unexpected result will happen, then why you have to take risk? So this is the way you can do it. You just write explicit actually before this particular constructor. So this is how it goes, guys, how to fix it. So then if this object is, so guys, actually when this particular, since you have made the constructor explicit, if this object is created actually and this argument is passed, that is character is passed actually, so since you are making the constructor as explicit here, actually this will not happen actually. So it will not compile the code. So this is good actually, because the whole program will not compile since you are making it explicit, and therefore it will not lead to the implicit conversion, and therefore you will not get an unexpected results. So guys, this is what all about it. So guys, however, know that making a constructor explicit prevents implicit conversions. This you know guys in C++. So guys, but even if you are so this is done some note points actually guys. By direct or uniform installation, still convert parameters to match. So guys, through casting also, even if you make explicit, one more thing is there. But if you do casting, then implicit conversions will be allowed in this format, guys. So this is just a note point for you guys. You can refer it, guys, later. So guys, all these rules I have mentioned, consider making a constructor and user-defined conversion member function to prevent implicit conversion errors. So this is what it is saying, that if you make explicit constructors or some member functions, this will avoid implicit conversions. That is very good actually, because it will avoid to unexpected results. So you can use in C++ level explicit keyword. So guys, this is all about the converting constructors and explicit. So as I told you in C++, prior to C++ 11, in C++ it allows implicit conversions through the constructor having only one argument, but in C++ 11, implicit conversions can be possible with the constructor having two arguments. Also, to avoid unexpected results, you can use an explicit keyword actually, as we have seen. So this is all about this feature, guys. I have covered these features in this part 3. So guys, be ready for the new features which I will be covering in part 4, that is override and final, as well as default and delete. So I'll be covering all these features in part 4. In similar way, guys, I'll be covering small features till part 8, and this is how we'll be completing all the features of C++ 11, guys. So guys, I'm done for now. Thank you guys. Thanks a lot.